Carsey here. In this question we've got a couple of vectors, u and v, with their components, and we're first of all asked to find an expression for u dot v. Now the process for finding the dot product is to multiply the corresponding components. So in this case our u components are p, -2 and 4, and our v components are 2p plus 16, -3 and 6. So we multiply corresponding components, the x components together, p times 2p plus 16. Then we take the sum of all these products of components. So we're adding y components multiplied together, that's -2 times -3. And then we're adding the product of the two z components, 4 times 6. There's a simplification needed. Let's get rid of these brackets. We'll have 2p squared plus 16p. And there's 6, positive 6, plus 24. That's 30. So we're getting a quadratic expression for the dot product. Let's have a look at the second part of that question. Determine the values of p for which u and v are perpendicular. So if u and v are perpendicular, then u dot v is equal to 0. Now remember, one of the definitions of the dot product is the length of u times the length of v times the cosine of the angle between them. And if the angle between them is 90, the cosine 90 is 0. Remember, the graph of cosine function 90 degrees is 0. So if they're non-zero vectors, and we find their dot product, this is not 0, this length is not 0, but the cosine of theta must be 0, and that means there's only one choice. The angle has to be 90 degrees. So if u and v are perpendicular, the dot product is 0. So in this case, 2p squared plus 16p plus 30 must be 0. And we have to find values of p where that works. Now there is a common factor. We should take that out first of all, make it slightly easier, and then we should be factorising that. So it's a couple of brackets. First terms in each will be p times p to get us that p squared. Then something times something gives us 15. 3 times 5. And the outside 2, that's 5p. The inside 2 gives us 3p. Now how do we get a plus 8p from that? We add them both. So both pluses there. So if that equals 0, so we have 2 times something being 0. One of these two factors must be 0. Either p plus 3 is 0, in which case that means p is -3, or p plus 5 is 0, in which case p is -5. So there's the two values for p which would make these two vectors perpendicular. So let's move on to the last part, part B of this question. Determine the value of p for which u and v are parallel. Now if two vectors are parallel, u and v are parallel, we should be able to write one in terms of the other. One will be a multiple of the other. So if we look at these components of these two vectors, and let's look at their y and z components, because their x component is not determined yet because it's got a variable p in there. So let's look at their y and z components. Let's take the z component. You'll notice that the smaller one is 1.5, or sorry, the larger one is 1.5 times the smaller one. 6 is 1.5 times 4. Take the whole of 4 and another half of 4 to get to 6. Does that work here? It works with the y coordinates. Take the whole of the y component, -2, then add on half of it, another -1, that will give us -3. So v, we notice, is 1.5 times u. Other way we could say is that the smaller one is 2/3 of the larger one. If we take 2/3 of 6, we get 4. 2/3 of -3, we get -2. So there's another way, saying the smaller one is 2/3 of the larger one. Either of these ways would work. Now, you'll notice that if we use the first one, if we double both sides, twice v would be 3 times u. And that's also what happens if we multiply both sides of the second one by 3. 3 times u equals 2 times v we would get. So let's use this relationship on the x components, that 2 times the x component, 2 times the 2p plus 16 would be 3 times the x component of u. We're using 2v equals 3u. Twice the x component of v is 3 times the x component of u. So that would be 3 times p. And we've got an equation to solve. Let's get rid of the brackets. That's 4p plus 32 equals 3p. Let's take away 3p from both sides. And then let's subtract 32 from both sides. So there we have the value of p for these two vectors, u and v, to be parallel. And it all hinged on the fact that if vectors are parallel, you can write one of them as a multiple of the other one. That's Mr. Corsi signing out. Hope you enjoyed the video.